We're going to continue in lesson 7.4, which was on finding the area of polygons or composite polygons. So kind of a thing, what we've talked about is that we're going to maybe get some shapes that are kind of strange looking that we're going to have to break into pieces. So like in this example, we could break this apart into two triangles and a rectangle. Again, you will be given the formulas for finding the areas of these shapes, but you'll need to write down the formula, substitute into the formula, and then to make things quicker, maybe you could use a calculator to work those out. This example is an example where you could use subtraction. So you could act like this was a whole rectangle, and then you could subtract out that triangle at the top. Okay? You could have done things differently. I mean, you could have done two triangles like this, maybe two triangles plus a rectangle, or you could have even done two trapezoids. Would be some other ways of figuring that out. So let's look at the do you know how. Number 5. So polygon has these vertices, and they want us to find the area. Vertices are like corner points. Vertices, it's the plural of vertex. So if we have one corner, I guess, would be a vertex, one individual corner. If you have more than one, then they're called vertices. So the first thing when we're graphing these, first thing to remember is these are in alphabetical order, X and then the Y. So you start at the origin, you start at 0, 0, and then you think about where you need to go. So if we're at 0, 0, we go over to 6 on the X, and then we go up to 2 on the Y. For 9, 5, we'll go over to 9 and up to 5. Okay? And so on. And what we're going to try to do here is graph all these points and then connect them together. Okay. Usually when they give you something like this, we can actually connect them in the order that they give these points to us. And that appears to be the case here. And so we've got some type of pentagon, looks like a home plate maybe, if you play baseball or softball. And so we're just going to look at this, and we're going to try to break it up into pieces and then figure out what the area is. And so again, the formulas will be given to you. You can see the ones we've been working with here. Area of a triangle, parallelogram, and trapezoid. Those 3 formulas will be given when you guys do these problems. So one way that we can split this figure up would be horizontally. We could split it up into a triangle and a rectangle. So for our triangle, and what I'm going to do, you might remember, is we can number our sections so we can kind of keep track of our work a little bit. So we can look at area 1 is a triangle. So I'm going to start with my formula for the area of a triangle. This is what I'm going to ask you guys to do when you do your tests as well. So you're going to write your formula down, then you're going to substitute, and then you can use a calculator if you want to make it quicker. Always, if you have time, it's a good idea to work it out by hand and just get the practice of doing them by hand as well. But you know, if there's a lot of problems, obviously I don't expect you to have to necessarily do that. So the base of our triangle actually is going across that red line that we drew in, is 6 squares across, so 6 units. And the height of the triangle, usually we talk about the height meeting the base at a right angle, so we could go straight up the middle here, or you could kind of think about from the side view how tall the triangle is. So that would be 3 units. And then we can work this out. This is probably not requiring a calculator at this point. We could probably just work this out. Half of 6 is 3, and then 3 times 3 is 9. Good. So our other section we have is a rectangle. So I'm going to start with that formula. Area of a rectangle is length times width. And if you notice the paper that we were mentioning earlier, area of a rectangle is not on there. So area of a rectangle is one that you would be required to memorize. Okay, you guys have been working with area of a rectangle for a while, so length times width for that. So one of the dimensions of this figure is 6. The other one is 6 as well. So this actually happens to be a square. So I didn't detect that it was exactly a square, but remember, a square is just a special type of rectangle. So we multiply 6 times 6 is 36, so 36 square units. And so once we've found those two, then we are going to add those two together, which would be 45 square units. And you can just write out square units or units squared. If you want to write it that way, you can. Square units, okay? Again, the work that I've shown here is what I expect you guys to write when you're doing these problems, okay? It is very organized, and it's not much room for somebody saying, well, what did you do from here to here? It's all right there, so you can all plainly see the exact steps we did. Also, it's less likely that you're going to make a mistake, which is the really nice thing about it. Okay, if we're organized with our work, we're more likely to get the right answer. We're going to look at some problems, workbook page 99, starting with number 3. So we are going to find the area of this T shape. So there's more than one way that we could do this problem. So if you didn't do it the same way as we're going to do here, you know, some of these kind of could be a choose your own adventure, and then hopefully we'll meet up at the end and get the same answer as each other. So one option is to split this horizontally and splitting this up into 2 rectangles. Okay? Another option would be to have split it vertically and kind of create it as a rectangle and 2 other little rectangles on the side, if you can picture that. Okay? Again, if you chose something other than this, we will see you at the answer, hopefully. So area of a rectangle, you need to make sure you remember that formula is length times width. So for our top rectangle, so our dimensions, the top rectangle are given 12 and 3, and we multiply those, would be 36 square centimeters. Now we're going to find the area of our second rectangle. So our longer dimension on this rectangle would be the 9 centimeters. The question is what the width is, which is that red line we drew in. Using the information they've given to us, if this is 4 centimeters here, and this is 4 centimeters here, if you look at the top, that was a total of 12. So kind of a side work here, I guess. You could argue this as being your second step, maybe. 4 plus 4 is 8, and then 12 minus 8 is 4. Okay, and so I'm going to change this up, I guess I'll make this my fourth step then. So when we do that, we've got 9 times 4, which is 36. And at that point, we will add those two together, which happen to be the same as each other, and we'll get 72. So 72 square centimeters would be our total area here. One thing you can do if you have time and you're doing a problem like this, if you have extra time, go back and do it a different way. Okay, like I said, go back and maybe let's split it up. You know, like let's make this one big rectangle, and then we've got 2 little rectangles on the side, and see what you get. You should get the same thing. Okay? So the next one, number 6, we're going to look at, they want us to find the area of the polygon in square units. So we don't know. Usually a grid like this, these are square centimeters, but it just says square units, so we don't know for sure what the measurement of each of these squares is. So one option would be horizontally. We could split this up, and technically it would be 2 triangles and a square. If we're not sure, we could call it 2 triangles and a rectangle. I'm going to do this a little out of order here. If you'll notice, I'm going to do my triangles first and then my rectangle or square. And you have to be careful with this. You might look at this and you might say, well, those 2 triangles are the same as each other. Okay, they might be. You always want to double check your measurements just to confirm that that's actually correct. So the base of our top triangle, if you count across there, that is 4 squares. So base is 4. And then the height, we can think about going straight up and down here, or kind of from the side. You could think about how tall the triangle is at a right angle to that base. So the height would be 3. And again, this is set up pretty nice for us because that first number is even. So if you wanted to, you could think about half of 4, which is 2. And then 2 times 3 is 6. Okay, so we've got 6 square units for our first triangle. Again, that second triangle I'm kind of thinking looks the same. What we want to do, let's go ahead and just measure that out and make sure that these are the same. So if we go across, is that base 4? Looks like it is, yes. And is the height 3? Okay, if you have 2 identical figures like that, you can go ahead and just tell me the answer is 6. And then you could just maybe make a side note and say identical to area 1. Good enough. All right, and then we've got one more. We need to find area 3. So it ends up, both dimensions of this are 4, so it technically we could call it a square. And if we do this, 4 times 4 is 16. And then one more step here. I guess I was not numbering my steps. It kind of goes in hand with what the areas are, the area numbers, so it's easier to follow that way anyway. Then we're just going to add those numbers together. So that's 28, so 28 square units. Again, we can write it square units like that, or you can just write out the word square units. So we look at number 7. City engineer plans to insert a storm water drain within a public garden space. The green garden space will be filled with rocks and plants that help to purify the water. What is the area of the space that would be filled with plants and rocks? Okay, so it says green garden space. I know you don't have the color in your books here, but that shaded part is the green garden space. Okay, you can use your imagination if you don't see that there in your books that way. So just that shaded part is the area that we're trying to find. So there's a couple different ways we could do this. So one option you might think of for this is we could take the whole thing minus the middle part. Area of the whole thing. Imagine that hole is not there, and then we take it out. It's kind of like making a rectangular donut here. So we have rectangles here, so we're doing length times width. So dimensions of that would be 15 and 15, so it's actually a square again. And then for the middle part, the dimensions would be 6 and 5. So if we multiply these, 15 times 15 is 225, 6 times 5 is 30, and now we're ready to subtract those. So we subtract, and that is 195 square meters. All right, like I said, there's other ways we could have done this problem. We could have, tried to somehow split it up into maybe 4 rectangles or something, but probably taking the whole thing minus the middle thing would be the most simple way of doing that problem. Number 8, Mrs. Vaya needs to buy grass seed for her yard. She drew a diagram of her yard. Each square represents 1 square yard, 5 pounds of seed. We got a lot of information here. 5 pounds of seed is enough to plant 100 square yards of grass. Grass seed is sold in 2-pound bags. And so the question is, how many bags of grass seed does she need? So one way we could split this up would be to draw a horizontal line here, and we split it up into 2 rectangles here, or maybe they're squares again, who knows. So 2 other ways that we could do this. One way, we could have instead split it this way and made a big vertical rectangle with another one next to it. Another way you could have done this would be, you could have made it like a big rectangle and then said, I'm going to subtract out that little part that I added into it. Okay? So however you wanted to do that, we should all come up with the same answers here. So if we did it this way, our first area is 6 by 6, which is 36. And our second area is 5 by 4, which is 20. So I'm kind of all over the place here, but 36 and 20, and then we add those together, would be 56. So area is 56 square yards. Once we find the area, one way of doing this, we could take that take 100 divided by 5. 5 pounds is enough for 100 square yards, so if you divide that out, that'll tell you that you can get 20 square yards for every pound of grass seed. And then we have 56 square yards. So if you take 56 divided by 20, that's 2 16/20 pounds that we need. So they're sold in 2-pound bags. So 2 pounds is not going to be enough. 1 bag, in other words, is not going to quite be enough. If we bought 2 bags, that would be 4 pounds. So that would be enough for us then. We'd have a little bit of extra grass seed doing it that way with 2 bags. So this gives you an idea of how to find the area of composite polygons.